Lesson 14.2, Permutations and Combinations. So this is a little bit more challenging, especially compared to 14.1. There's a lot here. Hopefully we can break it down. Unfortunately, it's a little bit experience-based, so you have to play with it and start to get good at it. It doesn't just come to you right away. So we've got two jobs, salesperson, cashier. We've got 4 people that can fill that job. So we could put A, B, and C, D with any of those jobs. And I'm going to make 2 charts just because otherwise I'd run out of space. So if A is picked as a salesperson, B, C, or D could be picked as cashier. If B is picked as a salesperson, A, C, or D could be picked as the cashier. Same thing for these two, C or D. We have the options of A, B, or D. Options of A, B, or C. That is 1, 2, 3, 4, 5, 6, 12 total. Ways. This is different than the work we just did previously because it's called the permutation. The order matters. It matters who's a salesperson. It matters who's a cashier. It wasn't 2 salespersons. I don't care if it goes A, B, or B, A. In this case, it mattered because we have an A, B here. We have a B, A there. Here and here. They're different. A, B is not the same as B, A. It's like the spelling of a word. Could have a word with so many letters, and if I mix them up with the same letters, it's not the same word. So that's what order matters means. That's a tricky one. You'll have to work on that to get your brain wrapped around it. Well, let's back up. This is permutations, and we just did a permutation of 4p2. Big number is always first, smaller number always second. This is what it means. Factorial means 4 times 3 times 2 times 1 on top. And on the bottom, we go 4 minus 2, which is still 4 times 3 times 2 times 1 on top. 4 minus 2 is 2, so it's just 2 times 1 on the bottom. We cancel. I've been having some problems with this lately. I think my computer is getting tired at the end of the year. We cancel the 2 and the 1. We're left with 4 times 3, which is 12. And that's what we had. Up here. 12 ways. So you might want to pause it and try these on your own. I'll get you started. No, you don't have to write the 1 if you don't want. 10 minus 6 is 4. You get 151,200. Try the other two yourself if you want. I'm going to do them now. My mistake. Zero factorial, as we've talked before, is 1. We just multiplied out 120. This is basically saying order matters. How many ways can we arrange 5 things? Well, that's just 5 factorial. To illustrate this, give you a couple examples. How many ways are there to arrange numbers in an area code? Well, an area code is 3 digits. There's 10 choices for each one. We're not going to worry about 411 and 911. So we have 1,000 different ways. Now, how many ways are there to arrange numbers in an area code if we cannot repeat a number? And let's ask ourselves, is the area code 1, 2, 3 the same as 3, 2, 1? I would say no. So order matters. If order matters, then it's a permutation. We're picking from 10 numbers. We're picking 3 of them. That's 10 factorial on top. 10 minus 3 is 7 on the bottom. Equals 720. So think about that for a second. Regular area codes is here. 1,000 choices. No repeats. 720 choices. This is a big deal. We have to get a new area code every now and then because everybody's got a cell phone and fax machines and work lines, and it gets a little frustrating. So we have to constantly add new numbers, and then we have to get new prefixes. So it's a big challenge for the United States to figure out how to get room for all the numbers. There's not an infinite number of them. We're going to run out eventually, so they have to figure out how to recycle them and things like that. That was a permutation. That's where ordered matter. What if order doesn't matter? We call that a combination. I'll give you some examples where order doesn't matter. One way would be, and it's a classic, a legislative body where you have a council with 5 members. Does it matter if Bob's the first member chosen to the council or Bob's the last member chosen to the council? He's on the council. He has an equal vote. So it doesn't matter. The only difference between the permutation and the combination is right here. I have an extra r factorial right there, and that's the second number, so you got to be careful and watch out. On top is still 10 factorial. And on the bottom is 10 minus 6, 4 factorial, which I'll put down here. And then also 6 factorial. These cancel, and I'll cancel the 6 and the 5. I'll cancel the 4 times 2 and the 8. And I'll cancel the 3 and a 3. We end up with 3 times 7 times 10, 210. Challenging stuff. See if you can do the next 2 on your own. Now I'm going to do them. A lot of people ask me, do I have to write the ones in? Of course not. I do it just to remember I've written it all out. This one's a little bit different. A lot of people freaked out by the result. And remember, order doesn't matter. I have 5 people. I want to put 5 people on the council, and I don't care who's first. There's only one way to pick them. If I've got 5 people and I choose 5, and order doesn't matter, pick your 5 people and you're done. So that's why you get the answer of 1. A lot of people confused by this. The math will set you free, but it helps if you understand what's going on too. Here's a classic. Pizza toppings. Now some people will argue with me, but we'll just assume for the time being that outside of the cheese itself, if I have anchovies and sausage and pepperoni and, I don't know, tomatoes, What else weird stuff do people put on there? Ham and bacon. I've got 6 toppings, and I only get to pick 2 of them. Doesn't matter which one I put first. The answer is no. So this is a 6C2, which I would just love to do the math for, but oops, I already did it up top. Right there. So it's 15 different ways I can pick those 6 toppings. So if you're arguing with a customer, they say, well, you don't have a lot of variety here. You can say, hey, there's 15 different ways you could top your pizza if you're going to pick just 2 toppings. If you do 1 or 3 or 4, there's that many more. You have 10 students running for president, vice president, and secretary. Does it matter who wins president versus secretary? Yes, it does. So you need to do that first. Say order matters. And then if order matters, it's a pure permutation. 10 people running, 3 being chosen. Minus 3 is 7. $720 different ways. However, if that 10 people were running for student council, councilman 1, 2, and 3, where there doesn't matter who comes in first or third, we should have a lot less. Order doesn't matter. So we get combination with 10 and 3. So it's the same thing we just had. And I'll just write the 720. But now we had 10 minus 3. We also have to have 3 times 2 times 1. Now there's only 120 different ways. A lot less. That's how the math works out. Always ask, does order matter first? If you're not sure, ask for help. That's the first thing you have to learn to figure out. And it's tricky. Although, honestly, there's really only so many choices I can give you. So many examples I can find. So, hopefully it won't be too much. We can use this to find probabilities. We've talked about this a little bit in the past. Probability is the number of favorable outcomes, or I would even say desired outcomes, or outcomes that you care about, versus the number of possible outcomes. What is the probability of rolling 2 6s? If you roll 2 6-sided dice. First things first, total number of outcomes. Well, this is just fundamental counting principle. There's 6 choices. 6 choices. Each die acts independently. There's 36 total. How many different ways can I get 12? Just the one. So, number of favorable, the outcome I care about, the one I desire, the one I'm looking at. It's just 1. So your probability, 1 out of 36. We'll go into more detail on probability. I wanted to give you a small idea what it's all about. That's it. Good luck.